Okay, at 12, here we go with the topic test on Trigonometry 2. Okay, so we've got these identities that we'll need to use, and we're solving trig equations. Let's have a little look. So first one, so I'm quite pleased this got featured in the first question because it comes up a lot throughout the test. So the cos squared we're going to use, that's the same as 1 minus sine squared. Then we're going to factorise the top because that's the difference of two squares. So that's 1 plus sine theta, 1 minus sine theta. We saw 1 minus sine theta on the bottom. Then we can cancel those two out, which leaves us with 1 plus sine theta. And that reoccurs throughout the test. On to question 2. So now we just expand out the brackets. And so we get sin squared theta plus 2 sin theta cos theta plus cos squared theta from the first one, and from the second one we get sin squared theta minus 2 sine theta cos theta plus cos squared theta. This is just obviously all we're doing here is just working on the left hand side. Okay, now obviously those two will cancel out, so we've then got sine squared plus cos squared plus sine squared plus cos squared, and that's obviously 1 plus 1, which is 2, which is what we're asked to do. For question 3, solve sine x equals minus cos x. So for this one we just need to divide by cos x, and so we're going to get sin x over cos x is equal to minus 1. Now sin over cos, as we saw in the opening slide, is tan, so we just got x is going to be tan to the minus 1 of minus 1, and that gives us 135 degrees. Now you don't need to worry about other solutions because as we know the period of tan is 180 degrees, so we can only have one answer in between 0 and 180 unless either of them were 0 to 180 and 135 is not. So that's all well and good. On to question 4. So we've now got cos, I don't know if you can hear in the background my child is going absolutely mad at the moment, but there we go. Hopefully you can't hear that. So we've got this equation, and we're going to be in 0 to 360, so it's probably just going to be worth us just drawing out cos, just like I was doing on Trigonometry 1. Just draw out the cos graph for this, just so we can see what's going on. We're just going to go between 0 and 360 to take it on a little bit further, like so. So there's 360 degrees is there. Oh dear, I need to get the sack right. Okay, back we go. Okay, so yeah, so we're going to say then that x over 2 plus 115 is equal to cos to the minus 1 of minus 0.5, and we can find from our calculator that that is 120 degrees. Obviously minus 0.5 is here, so if we just put a line across, we can see that we're going to have two possible answers. We've got this one, so that's 90 there, so that's obviously 120 here. So this one, we'd have this answer here. Now that's obviously going to be 360 minus 120, and so that is 240. So we've got two equations we've got to solve. We've got x over 2 plus 115 is 120, and we've also got x over 2 plus 115 is equal to 240. So if we're solving this one, that comes down to x is equal to 10, and solving this one, that says x over 2, believe it or not, that one gives us 250. Okay, right, moving on to question 5. Okay, so for this one, again it's very similar to what we had in the first question. So we're going to take this and we're going to change the sine squared into 1 minus cos squared, so just going from the left hand side again. So 1 minus cos squared over 1 plus cos theta, and then we can factorise the top because it's difference of two squareds into 1 plus cos theta, 1 minus cos theta over 1 plus cos theta, and those two cancel out, and there you go, we're left with that. Now hence for part B we can use that to help us. So this bit here is just going to turn into 1 minus cos theta, and then plus 3 cos squared theta is equal to 3. So we can rearrange that to give us 3 cos squared theta minus cos theta minus 2 is equal to 0. That I'm just going to let y is equal to cos theta for a minute. Let's do a little substitution. So 3y squared minus y minus 2 is equal to 0. We can punch it into our calculator or factorise it. If we factorise it, we know that 3 times minus 2 makes minus 6, and so we're going to turn this into 3y squared minus 3y plus 2y minus 2 is equal to 0, and so it's 3y y minus 1 plus 2 y minus 1, so that's 3y plus 2 y minus 1 is equal to 0, and so y is equal to minus 2/3, or y is equal to 1. Right, so that means that cos theta is equal to minus 2/3, or cos theta is equal to 1, because y is equal to cos theta. So for this one, that's going to give us theta is going to be cos to the minus 1 of minus 2/3, or theta is going to give us cos to the minus 1 of 1. Okay, so let's just draw this out before we have our calculations. There it goes. Okay, so first one to say is that's obviously going to be 1 there and minus 2/3 here. So obviously we've got these two answers here and here, and so that's theta is equal to 0 and 360, and we didn't even need to do any calculations for that. For this one, our calculator will give us 131.8 degrees, but seeing as you have got a cos, so that's obviously this answer here, so to get this one you're just going to do 360 minus 131.8, which gives you 228.2 degrees. So there we go. There's 4 solutions to that equation. Okay, alright, looking at 6 now. Again, very similar to an earlier question. We just divide by the cos theta, so and divide by the 5. So this will be the same thing as having sin x over cos x is equal to 4 over 5, and so that's the same equation as tan x is equal to 0.8. Okay, so then we just go x is going to be tan to the minus 1 of 0.8, which is 38.7 degrees, but we know that tan has period 180, so we're also going to have to add 180 to that, which is 218.7 degrees. So there's your 2 answers to that. Okay, so for this one, if we just invert sine it, we're going to get 2x minus 60 is going to be sin minus 1 of 0.5. So that will give us 2x minus 60 is going to be equal to 30. Okay, but we've got a little problem with this, and this is because of this 2x. So what we're going to do is we're going to draw out the graph again, and we can see there it goes. I'm going to do it twice. Okay, and 0.5 is obviously going across here. And I'm noticing that I've got these 4 possibilities. Now I've basically doubled it because I've got 2x. And we'll see how that's a good rule of thumb in a minute. Okay, so if we just so that's looking at this one from where we got the 30 degrees there. So we've got 2x minus 60 is equal to 30. So that gives us 2x is equal to 90. And so x is equal to 45 degrees. That's one. Next one is going to give this one. So also from sin to the minus 1 of 0.5, we've got 2x minus 60 is equal to 150. So that's just obviously, it's 30 here, so it's 30 here. So that must be 150. And so that gives us 2x is equal to 210, and x is equal to 105. Okay, we've got another solution here. That's obviously 360 degrees on from the 31, so that must be 390. So 2x minus 60 is equal to 390. So 2x is equal to 450, and x is equal to 225. So that's within the 0 to 360, even though 390 wasn't, the 225 is. So we've got to do that one. Again, this one will be 360 degrees on from 150, and so that must be at 510. So we've got 2x minus 60 is equal to 510. So 2x is equal to 570, and x is equal to 285. So that's again within the 0 to 360. So 4 possible answers for that one. Question 8. Solve these 2 simultaneous equations. So I'll call that equation 1 and I'll call that equation 2. For x between 0 and 360, answer to the nearest 0.1. So if we just take equation 1 and divide it by equation 2, the k's will cancel out, and we'll just get tan x is equal to 3 over 7. I appreciate that further maths are dead used to doing this stuff with dividing equations, and normal maths might not be, but you know, it is what it is, and we need to be ready for that. If we just inverse tan on that, so that gives us 23.2 degrees. Obviously it's tan, and so we'll have a second solution which will be 180 degrees added on to that, so it'll be 213.2 degrees. So those are our answers for x, but we need to find an answer for k as well. And so if we just go back to equation 1, k is going to be 3 divided by sin of either of these will both be the same, because that's what we just worked out, of course. So we'll just go for the smaller one, and that gives us k as 7.62. We don't, that's 0.1 degrees, it doesn't really matter what we put for k. Okay, so then for part B, again, if we look at the sin graph, k sin x, so the maximum is going to again be here. It's just going to be k, which just worked out, multiplied by 1, and this one, the minimum, will be k multiplied by minus 1. So the maximum, that's there, is going to be at 97.62, and the minimum is going to be here, which is going to be at 270 minus 7.62. Okay, and lastly we've got question 9. Prove this. Now, you've got 2 ways to do this. You can either start with the left hand side and end up at the right hand side. That's the easier way in this case. Or you start up with the right hand side and end up at the left hand side. We'll do both. You could do either. We'll just do both just to make sure that we've got all that done. So the first one, I'm going to start off by changing tan to sin over cos. Okay, then I'm going to multiply the 2 sins together. So I've got sin squared theta over cos theta. That's all over 1 plus cos theta. So now I can use what I've been using all through this that sin squared is 1 minus cos squared. It's a bit annoying that we've got this fraction within a fraction thing, but it's just sitting there, and all we're worrying about at the moment is just manipulating this top bit. Okay, so that's a little bit tricky now. So you might think, well, what's going on here? Well, I'm dividing this fraction here by this, so that's probably the same kind of thing as doing the fraction on the top, so the 1 plus cos theta 1 minus cos theta over cos theta, and then with the dividing it by that, that's multiplying by 1 over 1 plus cos theta. So we can now cancel those out, and we're left with almost what we want. We're left with 1 minus cos theta over cos theta. Then we can just divide through by the cos theta to give us 1 over cos theta minus 1, which does it. Now, if we had started with the right hand side, I say starting with the left hand side was still pretty hard. Starting with the right hand side, we can actually use some of what we just done to help us. So I've got 1 over cos theta minus 1. So that's going to be equal to 1 minus cos theta over cos theta. Just effectively adding the fractions. Then I can multiply the top and bottom of that by 1 plus cos theta. Okay, so that's now going to give me on the top 1 minus cos squared theta. On the bottom I've got cos theta 1 plus cos theta. Okay, so the top can now become sin squared theta. And I'm trying to put in every line here just to not leave anything out. I'm now going to just split that up actually. Split that up and make it sin theta over cos theta 1 plus cos theta, which is just really for display purposes, because now I can go, right, this stuff here is tan, so I've now got tan theta sin theta over 1 plus cos theta. So you can take your pick whether you wanted to start with the left or the right. It's entirely up to you. Both are a bit messy, and that's how you do it.